We're moving to the module, and we're going to be talking about variables. Talked a lot today about algebraic expressions. You can see once again we've got quite a bit of vocabulary. We're going to write algebraic expressions. Verbal. So this is part of our translation exercise. Early on in the year we talked about math is its own language, right? So we use more of that language. How do I translate? Then you're going to look at identifying the parts of algebraic expression using the math terminology. And lastly, we're going to do some evaluation.
Are we highlighting things?
Not yet, but we will be highlighting it in a moment. Because of the time and the fact that we're being recorded, we're going to skip the review for right now. And we're going to go into the second part. So here's what we're going to do. This is going to be our translation exercise. You're going to rewrite each statement using symbols. In other words, I'm going to take what's being written in English and I'm going to write it mathematically. If you haven't done this before, let me just talk you through it. I'll give you one example of what I'm talking about. That's what says 14 more than 6. So to write this mathematically, we're going to start using the actual numbers. So I know I've got 14, I've got more than, and 6. Big question that you need to ask yourself, two of them. Number one, what is the order? And number two, what is the operation? So if it's more than, what operation is that going to be?
Addition.
Addition.
Oh.
Right? No, exactly correct. Using an inequality. More than would be an inequality, but more than 6, 14 more than 6, you should be able to do that simply, right?
20.
It's going to be 20. But here's the key, and here's how you know it's not this, not more than, which is what you're saying, that's it's not an equality, it's 14 more than 6. But here's where this one gets a little tricky, because it's more than 6. So where am I starting?
Oh, is that it?
I'm actually starting at 6, but I'm doing more than that by 14. So this is how you say this in English. This is how you write it mathematically. Most of the time, you're going to just write it the way it's said. The one time you're going to have to think about it and switch it is what we call flipping phrases. More than is one of your flipping phrases. Okay? When I say more than something, it's actually saying I'm going to start at 6. I need more than that, 14 more. So technically, I would write that as 6 plus 14. So you've got 8 of them to do. This one will take you a little bit, so we're going to give you guys about 4 minutes. And then we'll go over it together. Try to do it by yourself first. Once you finish them all, then compare what you wrote to the other people at your table. A lot of stuff to cover. If I'm doing 6 more than 14, that one is just going to flip what we just did. So now it's going to be 14 plus 6. More than is another one of those flipping phrases. 7 less than 13. I mean, I'm going to go 7 less than 13.
Right in the paper, you do not have it correct.
23 subtracted from. Here's another one of our flipping phrases. Subtracted from 30 means I need to start at the 30 and then I'm taking 23 away from it.
Oh.
Okay. Quotient is a division. 12 divided by 4. For me, it's easiest to start this as a fraction, 12 divided by 4. You could have written it with the division symbol, or you could have actually, like you use the math, 12 divided by 4. Any of those would work. Okay? Quotient of 4 divided by 12. This one would be tricky for a lot of you because so many of you are used to the bigger number being first that a lot of you have trouble writing that. But that's okay. Again, I would start it actually on the fraction, 4 divided by 12. You could also have written it using long division, 4 divided by 12. It just means it's going to be a decimal for your answer. 1/4 of 28. Of is actually an extremely important word in English when you're translating the math. No. That's not it. Multiply. Of means multiply. So what this means, 1/4 times 28. 2 to the 7th power. 2 to the 7th power. We did the powers yesterday, so hope you guys got that one. Hope you remembered square to the special exponent. Which exponent is that? 2. Squared. It's just the opposite. This is one of the trickier ones on here. 2 times the sum of 4 and 6.
20.
What does that mean? Parentheses? What do I need parentheses for?
4 plus 6.
Addition. 4 plus 6. But it's 2 times that. So what do I do to the 2? Technically, it should go first because the way this is written. So it's 2 times the sum of those. The 2 times the sum. Now, mathematically, I'm going to do the 4 plus 6 first. That's why it's in parentheses. But the way it's written, the 2 should come out first. Would it be okay if I did this?
Yes.
Yes. Would it be okay if I did this?
No.
No, it would not be. Why?
Looks like a variable.
It looks like I added a variable in there. Okay? I don't mind if you do the dot. The parentheses need to multiply, so you don't need the dot. But if you put an X, you're wrong. Everybody good?
Yeah.
Does this make sense for you?
Yeah.
Did anyone get all of them right?
Yes.
It's impressive, honestly. Guys, there's one thing I want you to write at the bottom. And we're going to give you just a few of these. This is not all inclusive. You really need to read it. But the most common ones are more than, less than, added to, and subtracted from. So please write those 4 phrases down. Those are the ones that are going to trip you up the most often when you're translating from math to English or English to math. Because those are the ones that are going to flip the order of the numbers. It's not as important in the addition ones because we have the commutative property of addition that I can switch that order and it doesn't matter. Do I have a commutative property of subtraction? No. So if you don't like subtraction in the right order, you change the answer. So these 2 are probably the most important ones because it's going to change your answer. The other 2, technically you get the same answer, so it's not as important, but to be precise, you should still flip those numbers when you see those words. Dominic?
Can you get back up to 3?
Uh-huh.
Never mind. I thought you did this. I didn't.
Okay.
I'm glad you're checking his work. Good job.
I love it. I do make mistakes every once in a while. I think Aria Beach and listened to an entire year's worth and found one error that I made.
Are you?
Yes. Okay. Sometimes guys, you can write expressions even if a number is unknown. So if they've given it to you in English but they don't actually tell you the number, you can still solve it. So we're going to give you a chance to practice that. We're going to give you that the school lunch costs $3. So that's a given. Then we're going to give you a whole piece. Read situation. Write a numeric expression to determine how much money the school collected and then evaluate. Well, there are 2 different things, right? What does write the numeric expression mean? What does write the numeric expression mean? We talked about that last class.
It's like writing out questions and answers.
Writing out the question, but then evaluate means what?
It's like solve it. Make
Solve
it simpler.
The answer. So write the expression. Write the numeric expression says show me your work, show me what you're doing. Evaluate means actually solve it, get the answer. So you've got 3 problems to do. We'll give you guys about 2 minutes.
Okay, so what's important? What was the important information? Lunch is $3. So A says 55 students purchased a school lunch.
So what problem am I working out? 55 students times $3. And what do I get?
165. What do you mean 9?
$165. Yes?
Yes.
All right, then it says 26 students purchased a school lunch. What am I doing? 126 times 3, and what does that give me?
378.
Make sure you put that dollar sign. And 1,512 students purchased a lunch. 1,512 times 3 equals
36.
yes.
Got one.
Questions about those? Let's look at the next problem. It says, write a sentence to describe how you can determine the amount of money collected for any number of students who buy school lunches. So what would we do for any number?
I think you would one point amount of students by the amount per lunch.
So I would multiply the number of students by
3.
3. Thanks. We have a couple definitions that Mr. Moore's going to go over since he's our vocabulary.
Yeah, we all have your highlighters. We got a couple different definitions. First one, what we call an algebraic expression. Last class we talked about numeric expressions. We have 2 or more numbers put together with an operation. An algebraic expression is an expression that has at least one variable. So as we throw the variable in, now we change it from a numeric expression to an algebraic expression. That variable does make a difference. In an algebraic expression, if it is a multiplication, a number multiplied by a variable, then it's going to have a coefficient. If a coefficient does not appear in front of the number, it's understood to be 1. So if I just have a variable listed, technically there's a coefficient there. It's just that the coefficient is 1, and we don't write it because 1 times any number is that number. So it's kind of like mathematical shorthand. But anytime I have a variable, it actually does have a number in front of it. Here's a big key, and I'm not going to take a ton of time on this, but it is actually academically important, mathematically very important. And I saw this for most of you when you guys just did our opening exercise today. I saw a lot of you that wrote b times 32. Is that okay? Why not?
Well, I mean, that's okay. That's okay.
Property of multiplication.
Yes, we do.
Yes. So does it matter if I use b times 32 or 32 times b? No, it doesn't matter if I write b times 32 or 32 times b. Yes. Yes. Here's why. What is multiplication? For example, if I'm going to drop it because I don't want to do 32 boxes. If I did 40 for the days of the week, can I model that?
Yes.
Yeah. I can draw 40. So with this model, we use to represent that expression. Yeah. Okay. So now, 4. Can I now model that?
No. Can't do before.
So now I'm putting groups of 4, right?
So
Do I know how many groups of 4?
No.
So can I model that?
No.
Can I write that?
No.
No, mathematically. So technically, for most of you, it's opening up. Good. As soon as you make it qualification, the coefficient of funds come before the variance. Mathematically, that's critically necessary because I can't model it. If I can't model it, I can't do it. Does that make sense for everybody?
Yeah.
So, is everybody comfortable with the coefficient must come before the variance? Okay, I hope so. So, excuse me. Yeah, we just skip that part for now until I get to the second part. Nope, we'll skip 362. We'll do 363 though, because it's going to give you guys a chance to practice a little bit of this. What we want you to do, we're going to have you write an algebraic expression for each situation and identify the coefficients. So there's two parts that you are doing. Because we haven't always done this yet, I'll walk through the first one with you to help you understand what we're doing. Couple keys in this. Marking your text is really important, right, Zoe? Good. So once we mark our text, it's going to pull out that important information. Then assign tickets to the school play. How many will we have left if he starts with T tickets and sells 125? See how we mark our text? Now we have our question. How many is he going to have left? That's in your mind. You automatically set up what operation he's doing, right? What operation is going to be? What do I do to find out what I have left? Subtract. So then, if I'm subtracting, what you have to ask yourself is, what do I start with? T. It tells me it starts with T. Do I know what T is? No. But I can represent it. And what's happening to the T?
Minus 125.
I'm minus 125. Do I have to have an answer?
No.
I have to evaluate. I mean, we have to phrase it. No. But is this an answer?
Yeah.
You understand what you're doing?
Yes.
So you've only got 3 more to do. Hopefully it won't take you too long. We'll give you guys about 3 minutes. Identify the coefficient. Thank you. Actually, I do that. Here's my variable. What number is before it?
T.
What number is before it? If there isn't one, what number is it? You can't say it louder. 1. My coefficient is 1. If I don't have a number in front of it, then the coefficient will be 1. Because you're always multiplying. If I have an algebraic expression, it means that there's a number associated with that t. If I don't see that number, it's a 1.
So no matter what, if it's just a variable, it's just 1.
Coefficient is 1 unless they tell you that it's something different.
So no matter what, if they don't tell it to you, it's always 1.
Yep.
Yeah.
There's always a coefficient there. If you don't see it, it means it's 1. Okay? So
A plane descends to 5/6 of its cruising altitude. A. What is its new altitude? So what am I doing? What operation is it talking about? I hear subtraction. I hear divide. I hear what? Multiplication. Who thinks it's subtraction? What is your face?
Gemma eats my hand.
Can we change it to apple?
Yeah.
I thought you meant the inside.
Yeah.
Who thinks it's subtraction? Who thinks it's division?
Oh.
Multiplication. Yeah. I can do talking over people. Who can tell me what key word in our sentence tells us the operation, Max? No.
What? It's a.
Of. And what does of mean when you're doing? We go multiply. between those two. Yeah. Because the coefficient by a variable automatically means to multiply. What is it? The coefficient by variable automatically means to multiply. If you don't see any operation, it means multiply.
What's your closest?
I think that goes to part of the variable. I highlighted that on the last page. All right, now let's call $6 each with an additional membership fee of $10.75.
She just told us.
Oh, sorry, 5/6 is your coefficient. So that's what's in front of your variable. All right, C, you can tell me what the first part is. What am I doing first? Vanas? 6 times what? 6 times X, because it is $6 each, and I'm buying X downloads. Yes? Then what do I do? Somebody other than the person who already answered. Yes, because it says additional means to add. So what is our coefficient in this expression? 6.
Good job.
And the last one, headphones cost $35 and portable music players cost $75. How much does it cost to purchase X headphones and Y portable music players? Who can tell me my expression? You almost got called. Ariel? Okay, I need you to. I cannot accept that answer for the second time today. Technically, it is correct. But mathematically, it is not. Yes. No. 35 times X. Plus 75 times Y. Why was yours not correct?
Because they were different.
It's the same problem. But the coefficient has to come before the variable. So 35 and 75 are my coefficient. All right, Mr. Moore's going to go over homework with you.
What page is we got?
Yeah.
Mr. Wall, over
369, 370. This is the exact same thing Maya did last class.
You have two choices. Be quiet and I'll help you. Or keep talking and I'll just record it later. You guys can watch the video if you need help.
Like, are you going to do the answer or no? Oh.
Okay, girls, pretty easy. Find the difference in coefficient and term. Although we didn't quite cover that, I'll probably I'm not going to hit record right away. I'll go back and hit that page because it's kind of important. So you guys probably need to watch it anyway. This one, right, an algebraic expression representing each situation. So they've given you a piece, and I want to know the same number of pages in each folder. So they gave me a variable. How many pages will there be? You need to write an algebraic expression for that, and then the second part is going to be evaluating. So they're going to tell you what the pages are, and now I need the answer. Part A, I don't need a solution. I just need to have the expression written. Part B is where you're going to actually solve it. Same thing on part number 2. Then given $5 off your total bill. So how much will you pay after using the coupon if your bill is B? And then evaluate. Part number 3, you've already read 2.5 hours. How long will you read if you do an additional 8? So you have to think about what you're actually doing there, and then evaluate the expression for two numbers. On your back page, this one is just like we did. You're changing these to math. So write these as math. Then identify the number of terms and then the terms themselves. There are two parts to this. Most students missed this last year. You're going to need to listen to the video because we haven't told you what terms are yet. And then the last one, evaluate. All you're going to do, you take this number, you put it in where the variable is. So that's all you're doing for all of those. Okay? Good luck, guys. Okay, so here's the part we had to skip because of time, but this is actually a really critical part of the lesson. So we'll make sure we at least have access to it. Hopefully those that didn't get any class will come and listen to the video so they get this. And that is evaluating algebraic expression. Just like we did yesterday, once you see that term evaluate, what we want you to do is determine the value of the expression for a given value of each variable. So what we're doing on this, for example, they've given me this expression, 3x minus 4, and then they told me what x equals. Here's the key. Once they've told me what my variable equals, now I can go right in and I can just substitute that variable in to the expression itself. So now instead of x, I'm going to rewrite this as 3 times 10 minus 4. I'm not going to change any of the operations. All I'm doing is changing the number for that variable. You still have to follow your order of operations, meaning I need to multiply before I subtract. That would be then 30 minus 4. And then I actually do that subtraction, and that gives me 26. Okay? So you are still using the order of operations to evaluate algebraic expressions. If you want some extra practice, those problems are on the homework, or you can get a little extra practice here. It's on page 366 in your book. The other piece that we missed earlier is the term, the term. So this is another one of our academic vocabulary words. A term of an algebraic expression is a number, variable, or product of numbers and variables. So it's all of these different pieces that we put together to make an algebraic expression. One key, each term is each piece of that expression. So they've given us an example here. We have our first term is our 3x. In the 3x, we've got two pieces to that term. From our vocabulary earlier, the 3 is what we would call the coefficient. And the x is our variable. So our first term is those two pieces that are put together. They are separated by an operation. So that the plus sign separates us for our second term, 4y. And for y, we have two pieces again. We have a coefficient, the 4, and a variable, the y. And then our last one, there is no variable in there. Instead, we have another of our vocabulary terms, and that is a constant. A constant is a number that is by itself. There's nothing else with it. So if you have a constant, it's basically just saying a number by itself. So when I start looking at this, I have two algebraic expressions, 8 plus 5x, 8 minus 5x. What is the same in both and what is different? So we got two parts. The same is I have the same terms. They both have 8s and 5x's. So they have the same constant, 8, coefficient, the 5, and variable, or in this case, the x. So all three pieces of those are the same. The difference is the operation. So the operation between the two terms is different. Here's a piece that we didn't get to in either class, so I hope you guys are listening. Identify the number of terms and then the terms themselves for each of these. So what we're saying is how many pieces are there to this expression? So in this case, we have two terms. And then we're supposed to identify the terms. So my terms are a constant of 4. Which technically all you have to do is write 4. And then a coefficient and variable, which go together, is one term of 3x. So those are the two terms that are located in that. As we keep going on, now I have 3 terms. For your homework, what I have to do is say it's 4a, it's 9, and it's 3a. Okay, so hopefully that will enable you guys to be successful on your homework. If you have any questions, make sure you ask them in the seminar. Good luck, guys.